Now, you may have noticed in the previous video that we were starting to have problems where the numerator was sometimes larger than the denominator. All right, so we're going to start talking about proper and improper fractions, but also mixed fractions and how to convert, I guess, between them and their place. So the first thing is we need to know what a proper fraction is. And essentially a proper fraction is the one that I had when I first talked about fractions as itself, where the numerator is less than the denominator. Now the numerator is the top number of a fraction. So let's say I've got a numerator of 3 and a denominator of 4. We call this a proper fraction because the numerator now is less than the denominator. All right. However, so let's just call this proper. All right. However, when we have the opposite occur, so we'll have improper. Obviously, they're improper and improper fractions. When we have the reverse occur, such as 4 over 3, where the numerator is now larger than the denominator, we have an improper fraction. Improper fractions generally just, well, they do mean that we've got a value that's larger than 1. Okay, in this case, if we were to divide objects into 3s, and I sometimes like to think of this like pizzas. So let's say I've got pizzas and we were cutting our pizzas up into pieces of 3. All right. What it essentially means is I've got 4 slices of a 3-slice pizza. So when I'm shading this kind of thing in, it means that I have 3 slices on one pizza, like so. And I also have a 4th slice on a separate pizza. So it means that I've got one whole pizza here and 1/3 of a pizza here, which we can represent as, oh, whoops, that's not a 3. 1/3, so that's a 3 down here. So what it means is we can represent this as 1 and 1/3, okay, this improper fraction. Now, obviously, this is nice and easy to see while we've got a simpler improper fraction, but there is a quick method to be able to write a improper fraction into its mixed equivalents. So we know a mixed equivalent here is 1 and 1/3. The quick way to have been able to identify what that would have been is to actually divide the 4 by 3 and look at how many times does it go into 4. In this case, it's once, and that goes at the front. And then how many do you have left over once you've devised the 3 out of that? So in this case, we've got 1 left over, and that goes up here out of our 3 pieces. So the types of things that we might need to do, first of all, is we might need to convert a improper fraction into a mixed number. So we know where it exists on a number line. All right. So in this case, we've got 7/5. And yes, I could draw pizzas up and divide the pieces of pizza into 5 and we'll look at it that way. But my method that I'm going to use here is I'm going to look at this and go, how many times does 5 go into 7? Well, in this case, it goes in once. All right. And then how many would I have left over? Well, 1 5 is 5. So I've got 2 left over out of my 5ths. So this 1 and 2/5 is the mixed number equivalent. If we look at our next problem, we've got 11 divided by 2. Well, it doesn't go perfectly, but how many times does it go? Well, 2 goes into 10 5 times, but you've got 1 left over out of your 2. So the mixed fraction equivalent is 5.5. Now, anything we can do one way, we can generally do it the reverse. So if we have mixed numbers, we need to be able to put them back into improper fractions. To do that, the shortest way to do it is to look at, I've got 2 holes. Each of those holes is going to have 2 pieces. So if I go back to my pizza analogy for this, just so we can get a visual representation, I've got 2 whole pizzas and then another half a pizza. All right. But I want to think about those 2 holes as halves. So these 2 holes as halves is like this. So you sort of go, well, how many halves do I have? Well, I have 5 halves in total. All right, so 5 halves in total, which is how we sort of think about it. However, mathematically, without having to draw pizzas out, all we need to do is we need to go, well, we've got 2 holes times how 2. So 2 times 2 is 4, plus our numerator of 1 gives us our 5 out of 2. And we can do that with any kind of mixed fraction here. So over here we've got 3 wholes. Each of those wholes are represented in fifths. So 3 wholes of fifths will go 3 times 5 is 15. But we need another 2, so that's 17 fifths. And that's how we can break that down and represent mixed fractions as improper fractions.